Yeah, hello friends. This is Gangadhar with another question asking JEE Advanced 2019 Paper 2. See, the question is one of the easiest question of the paper. The question involves with the concept that integral as a limit sum. We are very familiar with this logic that integral 0 to 1 f of x dx is limit n tends to infinity 1 by n sigma r running from 1 to n f of r by n. This is one of the useful logic expressing integral as a limit sum. This is not only a useful one, this is a favorite one for the paper setters of mains and advanced, because usually we will come across with this logic in the questions asked in previous JEE mains and advanced papers. Now again, this question is based on that logic. See, the logic is integral 0 to 1 f of x dx, limit n tends to infinity 1 by n as sigma running from 1 to n f of r by n. So now here it is limit n tends to infinity. Now I am going to convert the problem into that one. And if you observe the problem, the question is this one now. Limit n tends to infinity. Sum of these and this one. The result is 54 is mentioned here. And they asked us to find the possible values of a. So to solve this one, my idea is using this integral as a limit sum. So I am converting both numerator as well as denominator as a summation. So I will write this numerator as sigma r running from 1 to n r power 1 by 3, right? And then similarly the denominator can be written as n power 7 by 3 sigma r running from 1 to n 1 by an plus r whole square. And now I am trying to express the numerator as well as denominator as an integral, as a limit summation, okay, to use the previous logic. For that, this is sigma r running from 1 to n r power 1 by 3. I will divide this r power 1 by 3 with n power 1 by 3, and then I will multiply with n power 1 by 3. I will do this one into n power 1 by 3 divided by n power 1 by 3. And again, here I have in the denominator, I need a function in terms of r by n, because the logic involves with sigma r running from 1 to n f of r by n, as I mentioned there. See, so I need a function in terms of r by n, so I pick out n out of this, it comes out and it becomes n square. So I will rewrite this one like this. How I will rewrite? This is a plus r by n square into n square, because the sigma is running over r but n square is not involved with r, so we need to pick it out. This is n square. Now, so I will use this n power 1 by 3 with this r power 1 by 3. In the next step, it will become like this is n power 7 by 3 and this is n power 1 by 3. I will rewrite it like this: n power 1 by 3 into sigma r running from 1 to n r by n to the power 1 by 3. The numerator is that one. And coming to the denominator, n power 7 by 3 by n square. So if you move this square to that, 7 by 3 minus 1. 7 by 3 minus 2. 7 by 3 minus 2 is minus 6, and then it is 1 by 3. So this is again n power 1 by 3 into sigma r running from 1 to n 1 by a plus r by n whole square. This n power 1 by 3 and n power 1 by 3 get cancelled. Now this is summation of the function r by n power 1 by 3, and this is summation of the function 1 by a plus r by whole square. So, but to convert it into integral, we need 1 by n into sigma r running, 1 by n into sigma r running from 1 to n f of r by n we need. So for that, I need 1 by n. So after dividing with n power 1 by 3, I multiply with 1 by n, both in the numerator as well as in the denominator. Right? Now, the numerator and denominator both are as a summation, that to a limit summation, because we have limit n tends to infinity for this one. We have that limit n tends to infinity. So now I will convert this numerator as well as denominator as an integral. Now the numerator will become integral 0 to 1 x power 1 by 3 dx. The denominator will become integral 0 to 1 by a plus x whole square dx. Finally, the given limit summation is nothing but this ratio of the integrals. This value is given as 54. First of all, calculate the value of this ratio of integrals and then equalize it to 54 to get the value of a. Now, coming to the calculation of integrals, the numerator is integral 0 to 1 x power 1 by 3 dx. It can be written as x power 1 by 3 plus 1, which is nothing but 4 by 3 by 4 by 3. What you say? X power 1 by 3 plus 1 by 1 by 3 plus 1, direct logic, with the limits 0 to 1. As well as in the denominator, this is 1 by a plus x square, that is a plus x to the power minus 2. We will write it a plus x to the power minus 2 plus 1 divided by minus 2 plus 1, and with the limits 0 to 1. Now, this 4 by 3 will become 3 by 4. We will express it like 3 by 4 of x power 4 by 3. If you replace 1, it is 1 minus 0. And coming to the denominator, this is 1 minus 2 is minus 1. Keep it out. And this is 1 by a plus x. In that 1 by a plus x, first you just replace with 1. So 1 by a plus 1 minus 1 by a. Right. This 1 by a plus 1 minus 1 by a minus 1. So I will calculate it like this. So that is finally 3 by 4 of 1 by a into a plus 1. This is 1 by a into a plus 1. Right? This 3 by 4 into 1 by a into a plus 1 is given as 54, and equalize it to 54 to get the value of a and a plus 1. Right? So this is the integration, and by applying the limits, I will simplify it like 3 by 4 into 1 by a into a plus 1, and we need to equalize it to 54 to get the values of a. So for equalizing, for the space, I am removing this. What I have now in my hands, I have this one. What it is? 3 times of a into a plus 1 divided by 4 is equals to 54. This is nothing but 3 18s. And then a into a plus 1 is again nothing but 72. Right. So a into a plus 1 is 72. Now check with the options. Clearly 8 9 0 is 72. 8 and 8 plus 1. And similarly, if it is minus 9 and if it is minus 8, then also it is 72. So from the options, the values of a are either 8 or minus 9. So finally the possible values of a are 8 and minus 9. Right? So this problem can't involve with any logic. This problem is directly an application of integral as a limit summation. Right? Thank you.